Okay, so for this problem, this is actually going to be an application of a small amount of physics concepts we actually got through our other classes. For this premise, we will actually be having you'll be having a conversation with two friends over Skype, not really specified, doesn't really matter over what kind of device. You're just having a three-way call, and you both live on the same street. So some friend A is 2 miles apart from you. Don't really need to write the full U there. And some friend B is also 2 miles apart. This is just completely east to west. And so that's the overall premise here. It's completely flat east to west. At some point, all three of you actually hear some kind of explosion. And the thing is, you hear this explosion 6 seconds before your friend to the east, friend B here, hears the explosion. Then, a total of 8 seconds after you hear the explosion, friend A to the west hears the explosion. And so this actually fits in with the definition of a hyperbola, because overall, from two sets of foci, the difference of the distance between the two should be a set number. And so we can actually create two hyperbolas from this problem, which is what we're being asked to do here. For the purposes of this, we're going to define east as positive and west as negative to match up with a standard coordinate plane. And additionally for this, everything will be in feet, hence miles over here, and sound will be moving at 1,100 feet per second. Okay, so ultimately we have to create two hyperbolas for each of these, and that is our overall problem. So first, let's actually start with the eastern hyperbola that we're going to be creating. Ultimately, we know that the distance from a point, we know that U is the focus, and we're going to say that U are at the origin here. So ultimately, one of the foci is at 0, 0. The other foci is at 10,384. Yeah, its mile is 5,184, right? Correct? Mile, feet in a mile. 5,184, right? Okay. So ultimately that means that we will be having 10,368. That is horrendously sloppy. Forgive me for that. 10,368 feet. And 0. Not enough space over here. 0, 0, 0, what? 10,368, 0. These are the two foci of our parabola. The other piece of information that we get is the amount of distance of time in between. Since we know that the distance from U is 6 seconds less in terms of speed of sound than the distance from B, we know that we can actually find the vertices through this, which gives us A. And we also know that this is a horizontal hyperbola. Oh, I just heard, it's actually 5,280 feet, so this will actually be 10,560. Again, forgive me for that. So, we know that for 6 seconds it's going to travel longer to B than to U. So, the vertex of this hyperbola will be somewhere will ultimately be right here. And this is U, and this is B. And this distance will be the distance sound travels in 6 seconds, which is 6,600 feet. These two distances are equal, and they're the distance more than the focus. Now, this actually gives us a bit of an interesting dynamic here. Right off the bat, we can simply divide this out by 2, and this is the distance from our center to our vertex, which means that this hyperbola can be immediately structured as x. First off, x plus 5,280, because remember, our center is actually between our two foci over here. 5,280 squared over 3,300 squared, which would come out to be, just wait a moment, $10,890,000. So that's a rather large number, but we're going to be seeing these rather large numbers with the sheer scale of this problem. So next we have the next term, minus y squared. Remember, the center is at the 0 of y, over what exactly? One thing we can actually do here is that we need to actually use the focus distance here, which is 1 mile or 5,280. Real quick, I'm going to finish this off with 1. And so, focus distance, a squared plus b squared is equal to c squared. So, a squared, 10,890,000, plus b squared, an unknown, is equal to 5,280 squared, which comes out to be 27,878,400. So, 27,878,400 minus 10,890,000 is equal to 16 million. 980. No, that's also not right. 70,000. No, it is 80,000. Never mind. 88,400. And so what this actually, and so this is the b squared, which is what gets put under here. 16,988,400. And that is the hyperbola that defines this section. Just going to erase this, make some space. And so, from this, one other thing we can deduce is that since we heard it first, the x value of this hyperbola must be less than 1 mile. Otherwise, the friend would have heard it first, not you. But that's not what we see in this problem. So, additionally, x must be less than or equal to 5,280. This gives us only 1/2 of the hyperbola, which lessens the amount of values we actually have to go through. Next, we have to deal with the western hyperbola. This one is slightly different, but not all too much. Foci are still the same. We still have a focus at the origin, us, But now the second focus is actually at negative 10,560. Awful handwriting. 10,560, 0. Still same 0. And rather than being 6 seconds, this is actually 8 seconds. So if we set up the model as before, we'd find that half of 8,800, as that's the amount of time speed would travel for, that would be our vertex. So instead of this being 3,300 squared, this is actually 4,400 squared, which would come out to be 19,360,000. Substantially higher. Same 19,360,000. Okay, actually, let's actually bring this down a bit. This is 10,890,000. And now we end up bringing in a new one, x minus 5,208. Remember, the focus is actually in the negatives this time. Squared. Gonna rewrite that 9 just so legible. Over 19,360,000. Minus y squared over, we don't know yet. But we do have the same way as last time. A squared plus b squared equals c squared. Now again, c squared is 27,878,400. So we can do the same manipulation. Minus 19,360,000. That is one too many zeros there. Which would get us 8,500,000, 518,400. And that's b squared.